Welcome to Revolution Against Evolution. I'm your host, Doug Sharp.
Co-host Rich Gear here as well, and we've got a very fascinating subject. One of the we've kind of talked about a little bit in the past, but the ideas of the metamorphosis of butterfly and the moth, and it's quite interesting, quite fascinating, and quite spiritual as well as physical ramifications, I think, Doug. And I think I like that in your outline. I think the difference we ought to tell our audience, a lot of people are not aware of, there is a difference between a moth and a butterfly. They're aware of that, but what they go into, a butterfly does not go into a cocoon, it goes into something called a chrysalis. You may have learned that in 4th grade or 2nd grade, but many people forget about that. But a chrysalis and a cocoon do very much the same thing, right, Doug? Is that kind of what it is?
Basically what it is.
And
the title of this show, we're just wondering what happens inside of the chrysalis. And of course, there are 4 different stages in the life cycle of both the moth and the butterfly, and we have to start out, of course, with the egg. The butterfly's lays the egg, and it's a tiny egg. It's you will see them on the bottom of a milkweed.
Well, the monarch butterfly especially. Yeah, not all butterflies eat milkweed, but the monarch does. What I was fascinated, Doug, we were looking at that, is that sometimes, depending on the circumstance, they'll lay their eggs on a toxic milkweed plant, and other times not, depending on, I guess, the predators or whatever. I guess it was fascinating to me. And if they eat the toxic mix, they're toxic their whole life, and predators won't eat them.
Right.
But if they don't, they won't be. You know?
No, but the birds really don't know the difference.
They don't know the difference, but it's interesting that when the predators are there, they lay them on the toxic, the milkweed that's toxic. But anyway, that aside, Doug, so we have a chrysalis, 4 stages. Start with the egg. That's pretty
you
simple.
have then the larva, which is the caterpillar, the pupa, which is the chrysalis or the cocoon, and then you have the adult.
Okay.
And what is fascinating to me is that you have actually a couple of stages that are like the egg, but the egg, you got this undifferentiated mass of stuff that all of a sudden gets forms into this caterpillar, and the question is, what is it in this stuff that causes it to start to form different parts of the caterpillar, like the legs.
And of course, all life cycles. I mean, look, you think of the human embryo or any animal thing. You go into these cells and they split and they double and they differentiate, start taking on things. What's interesting about the chrysalis cocoon, butterfly moth stage, when they go into that, it's almost like, Doug, they're going into a second birth.
Right. Yeah.
This is why I think it has spiritual connotations, which I think is very fascinating to me. Is you go these when we're all familiar with being born the first time. Right. Yeah. And what did Jesus told us? Unless you're born again, you cannot enter the kingdom of heaven. Because Nicodemus was very, what the heck? How can a man go into this? How can you go back into a mother's womb when you're full grown and be born? He says, you're a teacher in Israel. You don't know what I'm talking about. You're born of the flesh, you're born of water, and then you're born of the spirit. And what does that have to do with what we're talking about? It's like they're born, the egg is the first part. They go through life cycles, and they go through this larvae stage. And quite frankly, the way we live now, we're in the larva stage.
We're
really in the larva stage. Why? Especially when you're younger. You want. When you're larvas, all they do is eat and pork out. And it's all about themselves. And it's really hard in our life to think about something other than ourselves.
Now the caterpillar, it's all insects sort of like have an exoskeleton,
right?
And it's sort of like the caterpillar's got a flexible
which is interesting
skin.
in and of itself, yeah.
They will molt 4 different times, which means they'll sort of build this skin underneath the skin that's there, and they'll wriggle out of it. And, and they'll do this 4 times, and then the 4th time is when it goes into the pupa stage, or the
chrysalis or the cocoon. Right. That's the pupa stage. Interesting, Doug, because you talk about the cycles. we, in our life, is just from a human perspective, we go through different cycles too. We go through, we're a little infant, and we get into, we go to toddler, we get into puberty, then you get to be mature in old age. We go through stages too, though. In the larva stage.
Oh, yeah.
I'm not trying to say we're all a bunch of slugs. I'm just saying
Well, speak for yourself.
There is a reality here that we have to understand. We are not that great yet.
Yeah, that's right.
We need to have something happen to us, and that's why the Lord tells us. She said, "You must be born again, born of the Spirit." And to me, what's fascinating, Doug, we start talking about that corollary when it goes into the pupa stage. What happens there, Doug? Why don't you explain some of the stuff that goes on in there?
Well, it's interesting because you can actually, they've actually done an MRI of what goes on in this.
Wow, yeah.
And there's, you will see this shedding that final skin. It sort of scooches up. And the thing that's fascinating to me is that it survives this process.
I know.
This is a process where it works halfway into the pupa stage, and it's still alive, it's still working, and finally there's a spot where it's attached to the plant, and then it puts itself in this cocoon or the chrysalis, and then it's it just stops what it's doing, and all the cells within the chrysalis start to go into the undifferentiated state, almost like it goes into a jelly.
That's what I was getting at. It's amazing it's like when we die physically, you go, what does it say? Ashes to ashes, and
right.
to the ground we were made, to the ground you formed. We become undifferentiated again. Yet we don't, according to the biblical record, we're never going to be without knowledge, consciousness. We're going to be, but we're not in our final form yet. Not until the resurrection of the body,
right.
which is going to come at the end of the age. I think that there's an example in the butterfly, butterfly moth, chrysalis cocoon. Idea. You go into this chrysalis stage, in this cocoon stage, and then you shed your physical, your original physical form, in a sense, and you become
right.
Basically. In the old days, Doug, what they had to figure out there was jelly. They knew about this. You'd have to cut the cocoon open or cut the
right. Yeah.
Now they can do it with MRIs. That's kind of cool. They could probably see it through all the different stages of what's going on there. This green jelly. And it turns into this beautiful monarch butterfly, or a viceroy, or a swallowtail, or whatever it turns into. It fascinates me, Doug, because you don't think of a butterfly as merely an insect. You think of it as something as a neater creature. I don't know how many people out there have got, but one of my favorite things to do, Doug, was when I go up to Mackinac Island, go into that butterfly garden up there, and just to walk through them. Yeah, they're all insects, but you don't get creeped out by it. I said, you ladies out there, I know you hate June bugs. My wife, Carol, she said, how come you don't like June bugs? They got legs, Well, that was a great description. Well, so do butterflies, but you don't think of them that way. You think those great wings and those beautiful colors and the iridescent, the things they can do. And you also realize they don't really, they're not like the larvae. They're not consuming everything.
Right.
They really don't take on much of the.
They got a little job to do, though. And of course, they suck the nectar, and the proboscis, which is their little tongue, is in a Fibonacci spiral.
Fibonacci spiral. Yeah, we got a guy in our audience. He's liking that. He's our math guy. Yeah, Fibonacci spiral, huh?
Yeah, so it sort of uncurls and stretches out and sucks the nectar, and then it curls back up into its little pouch or whatever it is. And, and and so it also when it goes from flower to flower, it'll pick up pollen, and helps in the pollinating of plants. So there's a lot of things like bees and wasps and other things that do that as well, and we need to be aware of their roles in life.
Now you talk about I see a thing here about incomplete metamorphosis. What is that all about?
Well, there is a three-stage metamorphosis, and that applies to termites, grasshoppers, crickets, cicada, and aphids. And they go from an egg to a nymph, then to adult. So it hatches out of the egg into a very small representation of the adult, which is the nymph, and then it transforms into an adult. And so that isn't.
But they don't go through a stage where they literally become undifferentiated again and then come back and do this thing. So that's kind of different too. Maybe Doug, I'm not saying this is a direct corollary or anything like that, but maybe it's the people who they live this life, they go through the stages, but they're incomplete because they've never gone through the spiritual metamorphosis.
I know, yeah.
And this is all they'll go. This life is all you're going to know as far as anything good. And if it's bad, you're really going to be really incomplete. But I don't know, so look at what they are. Aphids, which we don't like generally, and nasty looking crickets and grasshoppers, which are called, it's one of the plagues of Egypt, the grasshoppers and the locusts, I'm just saying, I don't want to go too far afield, but it just interested me when I saw that about that too. But there's other things in nature too, Doug, that, we talked about, like, I asked whether do all the butterflies go through these four stages, and what about moths? What's the difference? And we know there's a difference between moths. One of the things I remember when I was a kid, moths have hairy antennae and butterflies have straight ones. That's the main thing. But I just was informed the way their wings open up or close.
And moths are more nocturnal than they are.
And more nocturnal than butterflies, with exceptions apparently. So but one thing I like is fascinating. We talked about how the monarch butterfly, especially, it goes through 4 cycles of where when they do the migration. And that, to me, that's a fascinating thing, Doug. If you want to talk about that, or unless we're getting a little out of order here, I don't know.
That's interesting. I once was, when we were in California, I visited Pacific Grove in the Monterey Peninsula.
And the butterflies.
And we weren't there when the butterflies gathered, but there's some special trees. They were actually eucalyptus trees.
Okay.
And the eucalyptus trees apparently were something that the butterflies liked quite a bit, and so that became their migration path. And they would gather on these trees, and they sort of protected them.
I see pictures of that. They're like covered, with these monarch butterflies.
And then once they migrate from there, they go to central Mexico, where they have oyamel fir trees.
So they like those too, then.
And so that's another spot where they winter. And then when they'll fly back north, and it's actually a super generation. There's actually like 3 generations that
to get to Mexico City.
Right.
Right, and then one generation flies all the way back.
Yeah, it's not Mexico City.
Or what'd you say?
It's in central Mexico.
Central Mexico. Okay, all right.
Yeah, it's like in the Copper Canyon area.
But it's in Mexico.
In Mexico, yeah.
But it's down. Okay, so it takes 3 generations to get down there, and then there's a super.
No, there's 3 generations that lay eggs. They go through pupa stage and die. Another generation goes through the cycle, but not on the migration. It's the 4th generation that migrates.
Oh, okay. Okay, well, I guess what I'm saying. So if there's 3 generations, they stay in the same area. They don't go to the California thing. They don't.
Right.
They're not. So it's the 4th generation goes to the California and Mexico. Right. Oh, I thought they were on the pathway there. I misunderstood that.
And there's like some. Cool. I remember in Arizona we were in the San Pedro Natural Conservation Area, and that seems to be a flyway for some of the migration paths.
So the 4th generation goes all the way down to Mexico and then comes all the way back? Is that what happens?
Right.
Wow.
So it's really, they call it a special super generation, and they live 8 months. And so that's mystery as to how that works.
Yeah.
Now the challenge here is for evolutionists to take all this data that we can observe about insects and construct an evolutionary path for it.
Yeah, well,
it doesn't work. How do you come up with this Rube Goldberg construction of things where you have the egg and goes into a fat grasshopper, and then it goes into the pupa, into the then to the adult lays the egg, and you go through this cycle. I don't know if you know who Rube Goldberg is, but he's a cartoonist.
He's an old gold guy, yeah.
Yeah, but they have cool. These cartoons of crazy machines that
had no purpose, but they look cool. A wing would remember the old game Mousetrap?
Yeah, that's what it is.
It's kind of like that. One would hit something, and at least in that one you had something where you'd end up catching a mouse in the end. But these Rube Goldberg machines, not even sure what you go. Let's just go out and shoot the thing, you know.
That's right, yeah.
You do all these things and knocks this thing, and people still do things like that with kind of like the dominoes knocking down, or I've seen these machines where something will knock 42 things down, and it knocks a spring and pops something up, drops into something else. Yeah, that's a Rube Goldberg machine.
And the thing of it is, you mess up any one of these steps, and the organism dies. It short circuits it, and so it's a problem. And for an evolutionist to explain, how this could have come about. And there's, you take the incomplete metamorphosis, which I was talking about, the crickets and those guys, and that is much different than the complete metamorphosis, which is moths and butterflies, and it's bees, flies, and ants do that as well.
They have the 4 stages?
Yeah, they have the 4 stages.
Okay.
Now, there's another insect which is quite fascinating. It's the mayfly. Oh. And the mayfly lives 2 to 3 years as a larva. Then for one day it emerges in the air to swarm, mate, and lay eggs, all just
and then
one
dies.
day. Yeah. And the fish like this, and there's a few other different kinds of insects like this. There was one called the hex that Steve talks about. He always wants to go fishing during the hex hatch, because
the insect called a hex.
Well, it's a Lepidoptera or something like that.
Oh, okay.
But it's hex for short, and this is another type of insect, just like the mayfly, that lives only just for a brief period of time before it dies, and so of course it feeds the fish, and
fish like it, yeah.
And fish like it, yeah. And so this is an interesting thing. There was a write-up in here that I'll see if I can find it. But these guys were trying to explain the evolution of the monarch butterfly.
Were they evolutionists?
They were evolutionists.
They were evolutionists. Okay. I always love them. They're ad hoc, after the fact explanations, which are really talk about Rube Goldberg explanations is what they are.
Okay, so
you found it?
I think it's here.
All right.
In the 1999 issue of Nature, 2 scientists, James Thurman and Lynn Ridderford, presented their hypothesis how complete insect metamorphosis evolved. They tried to explain the evolution of the 4-stage metamorphosis from a 3-stage metamorphosis by proposing that the latter actually contains 4 stages. They call this arbitrarily defined 4th stage the pro-nymph, and described it as a period that always precedes the first molt, and which varies in duration among the different species, sometimes ending as soon as the insect hatches out of the egg. The pro-nymph, they argued, evolved into our modern larva. In plainer terms, some ancient insect hatched out of its eggs too soon, began groping around for food, and continued evolving until it could spend many weeks in this premature caterpillar-like form before finally metamorphosizing into the long-belated nymph stage, which, according to the authors, had shortened and evolved into our modern pupa.
That really didn't say anything.
Yeah,
that is really
that's a stretch.
No, it's just like, okay, I could write a science fiction novel or a horror novel where a man turns into a bat, but I'm saying what? That's fantasy. It doesn't really make any sense at all.
Well, here's the thing. If you want to prove that there was some sort of insect evolution, you need to find fossils of insects that look that sort of map out this proposed evolutionary
sequence. As far back as we go, all the insect fossils we found, they all look the same today as they do back in the.
There's a fellow by the name of Joaquin Chevin, and if you remember, we visited a fellow in South Africa who gave us a book by him.
Oh yeah.
And this is a German fellow who did a research on insects found in amber, and he compared them with insects that are found today and found them to be identical. So this book, which is in German, and I think your daughter-in-law now has it, but it's a beautifully illustrated book.
I remember the German. Yeah, what was his name?
His name was Joaquin Chevin.
That was the name of the German guy. Okay,
yeah.
All right.
And so his take on it was that you don't see any evolution of insects, and if you find a fossil imprint of an insect, no doubt you're going to find it mostly identical to what we see today.
The only difference I've been able to see is maybe size.
Size, yes.
Yeah, that's the only thing you see, like 2-foot dragonflies and things like that. But
and so we can explain like a bigger insect with a different environment that would have preceded the flood. And so because something that would have been buried during the flood, insects, could have been the things that we see that would have been from the environment that was created to last forever. You might have had a 400-year-old
400-year-old dragonfly, huh?
Yeah, right. Yeah.
Well, he probably wouldn't have a 400-year-old, but correspondingly, human beings, they live 70, 80 years on average, insects living 8 months to 3 years or whatever, probably.
Right, yeah.
Yeah. And then you go to 800, 900 years before the flood, maybe they could have lived 20 years, 30 years. Yeah,
we're talking, for humans, it would have been 10 times a lifetime.
Yeah.
From 800, 900 years. Whereas the insects, if they live for a day, well, maybe for 10 days.
They live for 10 days. Ooh, a long time. Well, the dragonflies make me go. No, there's something else. Just one more thing. I don't know. We might be getting short on time, but I saw a little thing in your outline there about mimicry, which I thought was kind of fascinating.
Oh, yeah.
To me, that's another difficult thing for evolutionists to really explain very well. I think it's just, one of my favorite ones, of course, is you got the monarch butterfly, and then there's a butterfly called the viceroy.
Viceroy.
Which really, it looks a lot like the monarch. But it's different, I've learned in the past when I was in science class when I was a kid, but I can't remember what it is right now. Like the spots are reversed or something. I can't, but it's something different about it. But they look very similar when you're just looking at them.
Right. And predators don't like the viceroy, not because it doesn't taste good. It's because it looks like the monarch.
Yeah, which they know might be bad for them.
And so that's sort of like a protective mechanism. And the scientists will try to assign some sort of meaning and purpose to that, and by doing that, they defeat their own argument.
Well, yeah, they anthropomorphize nature is what they do, and they say, well, yeah, they like an insect can think, and so I want to turn into this so I don't get eaten. Are you kidding me? That just doesn't make any sense at all. Like really, when you put it that bald-facedly, it sounds ridiculous. It's amazing how many times you can maybe justify, the ancient theologian argument, how many angels could dance on the head of a pin. But I tell you, there's so many how many times can wings evolve? How did mimicry evolve? How did symbiosis, or if you will, how all these things evolved? And the more they study, let's say the DNA and the molecular complexity of cells, it gets worse and worse and worse for the evolutionists.
Yeah, and what they call it is convergent evolution.
Well, we know what they call it, but that's a...
Yeah, and if you put a name on it, then it gives it some sort of scientific
some kind
credibility.
of scientific street cred, right? But not to me it does. It's just you put a name on something. And you got 4 different, and an insect wing, and a bat wing, and a reptile wing, and a bird wing are totally different. And a mammal wing, they're all different.
The flight evolves 4 different times.
Yeah.
And so that is a big problem for evolutionists, is trying to figure all that out. Then you have all these beetles, millions of different kinds of beetles, and the beetle, of course, has this little hard wing on the top of it, and
What's that called? A carapace, or what do they call that? The hard shell, or whatever. Yeah. The beetle. That's what I don't know. Is a June bug a beetle?
it is, yeah.
Oh, yeah. Carol did not like those at all.
I remember my dad once handed a guy something like that. Here, take this, and it was a June bug.
They freak out. They don't bite. They don't spread disease, as far as I know. They're just kind of like there, and they look creepy and ugly, but they don't really do anything.
They're buzzy though, and
they're buzzy, and they got legs, like Carol's.
And the cicada, they're a big creepy thing too, and they have a 17-year life cycle.
Yeah, those guys could live a long time. I could see a 2-foot cicada, because if they live 17 years, they might live like 100 years, man. If they're 10 times life cycle, 170 years. Mm-hmm. Wow, that's a long-lived insect, man. That's a long-lived insect.
Well, let's put this in a creationist perspective of why you see stuff like this. And that's because God, when he designed things, he has these computer subroutines that he borrows from here, borrows from there, something that looks like this, something that looks like that, and he takes that code, and when he assembled it and put it into the DNA to put together his creation, he made the stuff all different, but by using the same created code that he started out with. And so you're going to find similarities between different things, even down to the code level, because it's going to be similar and yet different.
Well, that's the thing. There's a book you gave me. I can't remember what it's called. The God Principle. It's like it's infinitely complex and yet remarkably simple in its form, and yet it's infinite in its variety and what it can be done with it. That to me was it's simple and complex at the same time.
And when you call it object-oriented programming, because what you're doing is you're taking an object, something that's created to do a certain job,
right? And
you're taking it and borrowing it and putting it over here. Maybe putting it in a different environment, but it's going to perform that same function and do the same kind of job.
That's amazing. That is amazing.
We'll see you next time on Revolution Against Evolution.